Hey everyone, Linus here. Let's talk about system programming. It's the backbone of everything we do in tech. Operating systems, game engines, you name it. And for a long time, C and C++ ruled the roost. Don't get me wrong, they are powerful tools, but they come with their share of issues, especially memory management. Enter Rust, a language that's changing the game. Rust is all about performance, reliability, and safety, a killer combo. It's designed to eliminate those pesky memory-related errors that plague C and C++. Plus, it's blazing fast. We're talking close to the metal performance here, folks. Rust achieves this through its unique approach to memory management. Instead of relying on a garbage collector like some languages, Rust uses a system of ownership and borrowing. This system might seem a bit different at first, but trust me, it's a game changer. It ensures memory safety at compile time, meaning fewer crashes and vulnerabilities in your software. Now you might be thinking, okay Linus, this sounds cool and all, but is it really that revolutionary? You bet it is. Rust isn't just a cool new language, it's the future of system programming. And the best part? It's gaining serious traction in the tech world. Big players are taking notice and adopting Rust for their projects. Let's dive deeper into what makes Rust so special. First off, memory safety. It's the holy grail of system programming, and Rust nails it. Remember those ownership and borrowing rules I mentioned? They're the secret sauce. Think of it like this. Every piece of data in Rust has an owner and you can lend it out temporarily. But once the owner goes out of scope, the data is gone, deallocated automatically. No more dangling pointers or memory leaks. But it doesn't stop there. Rust also prevents data races, a nightmare for multi-threaded applications. Data races occur when multiple threads try to access and modify the same data simultaneously, leading to unpredictable and often disastrous results. Rust's ownership and borrowing rules combined with its powerful type system nip this problem in the bud. And now, the big question, performance. You might think that all this safety and reliability come at the cost of speed, but you'd be wrong. Rust is incredibly fast, often matching or even surpassing C and C++ in benchmarks. How is this possible? Well, Rust doesn't rely on a garbage collector which can introduce performance overhead. Instead, memory management is handled directly by the compiler at compile time. This results in lightning-fast execution speeds and predictable performance. Okay, so Rust is awesome, but don't just take my word for it. Look at the tech giants who are jumping on the Rust bandwagon. Microsoft, known for its Windows operating system, is increasingly using Rust to build secure and reliable system components. They even have a dedicated team, the Rust and Windows team, focused on integrating Rust into their ecosystem. Amazon, the e-commerce behemoth, is another major player embracing Rust. They use it extensively in their cloud infrastructure, particularly for building high-performance and secure services. Amazon Web Services, AWS, even created their own Rust-based language called Tokio for asynchronous programming. Dropbox, the file hosting giant, switched from Python to Rust for performance-critical components of their file syncing engine. The result? A significant boost in speed and efficiency. These are just a few examples of how major companies are leveraging Rust's power and reliability to build the next generation of software. Now let's address the elephant in the room, C and C++. These languages have been the go-to for system programming for decades, and for good reason. They're powerful, versatile, and give developers a lot of control. However, they also come with their fair share of baggage. Memory management is manual and error-prone, leading to vulnerabilities like buffer overflows and dangling pointers. Concurrency in C and C++ is notoriously difficult to get right, often resulting in data races and other concurrency bugs. Rust, on the other hand, is designed from the ground up to address these issues. Its strict compile time checks and ownership system eliminate entire classes of memory-related errors. Concurrency in Rust is safer and more manageable thanks to its ownership rules and data structures like channels. While C and C++ aren't going away anytime soon, Rust offers a compelling alternative for building secure, reliable, and performant systems. It's the future of system programming, and it's exciting to see how it will shape the technological landscape in the years to come.